Welcome back to part 2 of conics. So we need to look at some equations. So the equation I'm going to look at the moment is for both the ellipse and the hyperbola. So for the ellipse, the equation should be x squared plus a over a squared plus y squared over b squared equals to 1. So that is for an ellipse, and for a hyperbola we get x squared over a squared minus y squared over b squared equals 1. Now you can see that there's only one really significant difference, and this is the minus, and this indicates to us that we're actually dealing with a hyperbola and not an ellipse. Now the only other thing for hyperbola is the idea around asymptotes. So if we would like to look at the formula to start with, so the equation for a hyperbola is x squared over a squared minus y squared over b squared, and this equals 1. So another way to write this is y equals plus or minus bx over a square root of 1 minus a squared over x squared. From this it can be seen that since the maximum value of this part here is 1, it can never exceed bx over a, or it can never be less than the hyperbola minus bx over a. So these become our asymptotes. So the curve lies entirely between the lines of y equals bx over a and minus bx over a. So we can also see as x approaches infinity that the square root of a squared, 1 minus a squared over x squared approaches 1, and the way we can write it is y equals plus or minus bx over a. And this will help with the example in the book that came across as a little bit confusing. So there is one more formula that we need to look at, and we can do this through a problem. So basically I'm given the problem that any point x and y, the focus of our image is 0 minus 1 and the directrix is minus 3, and it has eccentricity factor of 1/2. So I've labelled these P, S, D. And what we know to get E is that we have PS, so the distance between the point to the focus, over PD, so the distance from the point to the directrix, should equal 1/2. And I can rearrange this and then try and work it out. So we need two distance formulas. We have the distance formula, between a line, so we can use the square root, which we know, but we also have what's called a perpendicular distance formula. So we need to rearrange the equation for the distance for what we know as the PD. So the perpendicular distance formula is ax1 plus by1 plus c all over the square root of a squared plus b squared. And that's what we're going to look at doing now. So we can rearrange this equation here to give us, so the distance between the point and the focus equals 1/2 of the distance between the point and the directrix. And then we can just use what we know as distance formulas to put them in. So I'm just going to flip the page. What we get is the square root of x minus 0 squared plus y plus 1 all squared. And why we've put this in, sorry, that should be a minus 1 because that's the minus point. Why we've put it in like this is that it comes from the measurement of the p value, which is the point xy, and the s value, which is the focus of 0 and minus 1. And we do change that sign to a plus because it is minus 1, and that's where we get the plus from. And we say this equals 1/2 of the general formula of the directrix, basically. So 1/2 of y plus 4. And when we rearrange this, we can get 2 outside of x squared plus y squared plus 2y plus 1, just expanding what's inside, and it equals y sorry, they should be y plus 4. Okay, so now we get to get rid of the square root. So if we get rid of the square root, we're going to square everything else. So we end up with 4x squared plus y squared plus 2y plus 1. And that equals to y squared plus 8y plus 16. We're just going to do a lot of simplifying, and what we get down to, if you would like to pause and simplify that, to double check, we get 4x squared plus 3y squared equals 12. But this doesn't look like any of the formulas we've got. So we're going to start to simplify. And when we simplify, we end up dividing everything by 12, because remember all of our formulas equal 1. So we get x squared over 3, because 4 divided by 12 is over 3, plus, well, 3 divided by 12 simplifies to y squared over 4, which equals 1. Well, what is this shape? If you think about it, it's not a circle, because otherwise they'd have the same numbers down the bottom. We know that it's close to a circle, but this indicates that it's a bit more skewed than normal. So what we can do is that we can say, okay, then this is a ellipse. To draw an ellipse, though, we need to know what our intercepts. So if I want to draw an ellipse, I can work it out. And we say, okay, when x equals 0, then that part of the equation must be 0. So then we have y squared over 4 equals 1. And so therefore we know that the answer to this is y equals 2. And then we have a flip side of it when we do the x, and we find out that the x value is equal to the square root of 3, plus or minus the square root of 3, which works well. So we also know this is plus or minus 2, because to get here we had to square root it. So we can put these values in, make sure you label your axis, and you can see that it is an ellipse. So we want another, example. So we say that our S value, so we worked that out before, that's our focus, is 4, 0. Our D value is x equals 1. And our E value is 2. So our point is x and y. Okay, so to work this out, we're once again going to set up our equation where we had PS over PD equals to 2. And when we rearrange this, we get PS equals 2PD. So we need to create up our equation like we did before as well, so we can get our square root sign is x minus 4 all squared plus y squared. And what it equals is it comes from the perpendicular general formula, which you might want to do more research on if you want. X minus 1 is the general form of this equation here. So if we're going to write it out to have some more clarity, is 0 squared plus 1 squared. Alright, so then we start simplifying our equation. So we get x squared plus 8x plus 16 equals y squared. Sorry, plus y squared. And then we go through to the other side because we're squaring everything. And we've dealt with the bottom. This is just 1. But on the top, what we get is if we square it all, we get 4 outside of x squared minus 2x plus 1. Okay, so then we get all the way down. If you keep simplifying and changing it, what you get is you get x squared over 4 minus y squared over 12 equals 1. Well, these numbers aren't very close, and how we know it's hyperbola is because of this point here. It looks very close to an ellipse, but we have to be aware that it does have a negative in between it. So we need to know how to draw it. So we need to work out what the asymptotes are. So if you take a moment to pause and have a look, let's look at what the asymptote should be.